So we made a simple light meter here by just taking a photocell and connecting it to a resistance meter, a multimeter. So we have a photodetector, and what we did last time, same as last time, we took our photodetector and we made it, and we connected it to a multimeter and so that we could take measurements of the amount of light. So we have two wires here to the multimeter. This allows us to measure the quantity of light as a change in resistance. And then we can now plug this into the multimeter. Off the test leads that were on there originally, or we can attach the same test leads, but in this case we simply take out the test leads and put in this multimeter, and now we have a way of measuring light. Right now 110 ohms if I point it up at the light. If I point it a little bit not straight at the light, it's bit more resistance, like 530 ohms. So now last time we had a light bulb and we covered up half the light bulb to get this comparametric. This multimeter this light meter is a device under test. So we've built a device under test. So we're not considering this to be a measuring instrument. This is part of the device under test. So this whole thing is the device under test. And so this device measures light, and we can walk around with it and bring it in closer to the light, and as we come closer the resistance goes down until we come right up close to the light. Now it's like 20 ohms or 24 ohms, 36 ohms, it's varying around fairly low resistances when it's in close to the light. And as we come further from the light, we'll pick up other light sources in the room, of course, but generally the resistance increases. And we want to understand this measuring instrument. This whole thing is a measuring instrument, and that we want to calibrate without using any other measuring instruments. So this is part of the device under test, but apart from that we're not using any other measurement instruments, and comparametric equations is useful to understand things that are either difficult to measure or inconvenient to measure, or it provides a unique way of understanding things. So we took the light bulb last time, we covered it half up and opened it up. Now another approach would be to use two light bulbs. If we took two identical light bulbs and we screwed them into something like this that has multiple light bulbs, and put them like this so that they were presented to the photodetector, we could take the resistance with both light bulbs running and then unscrew one of the light bulbs and take the resistance with just a single light bulb running. So if we were to look at that, look at a comparison of resistance with one light bulb running against resistance with two light bulbs running, we would be able to see, make a comparametric relationship formulate a comparametric relationship. There's a light bulb. We have to find two that are the same. So the problem is these are slightly different. That one's a little bigger, and so we're looking for two identical light bulbs. I have some new bulbs here. These ones here, we could take two of these light bulbs and compare them. And if they're the same, we can use one bulb versus two bulbs, and that's simple enough that would allow us to easily understand the relationship between the bulbs, because we have one unit of light and 2 units of light. And in fact, there's 2 bulbs that are quite identical. And these are a little brighter also, which is kind of nice. And then what we would do is position this a certain distance from the photocell there, and then check the resistance reading, and then see it's like 90 ohms, and then we would unscrew one of the bulbs, so there's only one, and then we move it closer until it reads the same 90 ohms, and it gets about there, roughly in about this position here. It's about there, and then we'd screw in the second bulb, and then we went from 90 ohms to 68 ohms. So we do the same pattern there and go through the same experience pattern. But now what is interesting is that, see, I have 6 lamp holders in this circle, and what I can now do is I can put 6 lights in a circle. It's actually got 7 lamp holders, but I would not use the middle one, because the middle one's not the same distance from the other two, from the others. So if we were to look at this, there's a circular thing here. There's 6 light bulbs here, and then one in the middle, and I would not use the middle one because it's not equally spaced, but the others are all uniformly spaced. You see, they're radially symmetric to the photodetector, so they'll produce equal contributions to the photodetector. So if I wanted to, I could put 6 bulbs in there and loosen any number of them. I could have 1 bulb on, 2 bulbs on, 3, 4, 5, or 6. And the smallest increment, the smallest ratio comparametrically I could get would be 5 versus 6. That's the smallest increment. So if I have 5 lamps on, that's 5Q, and I go to 6Q, that's a 20% increase. So that's increment times multiplication time of 1.2 times. So that is a very small increment. And what we'll see when we look at differential equations in terms of comparametric equations in terms of differential equations is that desire to get this sort of small amount. So we want to go from 1 to 1 plus some small amount epsilon. And in fact, if we could get that amount even smaller, that would be even better. So what I've got here is we prepared a ring of LEDs. There's 42 LEDs on this ring, and they're in groups of 3. They're connected in series in groups of 3. And so each group of 3 LEDs in series forms the next increment, so you can only address them in groups of 3. So what we are going to do here is turn on all of them, and then turn them all on except 3 of them. So this is 42 lights in groups of 3, so that's 14 lights in each group of 3. So there's 13 lights if we turn off one group of 3, so we'll have 13 over 14. So we'll have an even smaller increment of 13/14. So we're going to go from 13Q to 14Q. And so that's a very small increment, and that will allow us to unroll that comparametric relationship to an even finer degree. So if you have some comparametric relationship here, and we're trying to explore it or understand it, we're coming along, going up, and you take that much, come around, that much, go up, take this much, come around, go that much, and go up, and so on. If we can do that in a smaller increment, we're able to take this in a much smaller piece, and we can get much finer increments of that solving numerical solution of the comparametric equation. So this is how we do this, is we take, in this case, we've got our light meter here, and what we're going to do is we're going to power up this lamp here and power up 13 of the lights and measure how much light there is, and then power up 14 and then move it towards the light. So we'll start at some distance from the light, like say over here at this end of the table. And then we're going to move closer. What I'll do again, as I did before, is I'll turn off the light sources in the room, starting with this television here, and turn off the TV, and I'm going to turn off this light as well, and I'm going to turn off that light, and then I'll turn off this light over here, and I'm going to turn off my workbench light, and I will also grab this power supply from my workbench before I turn off the light, because what I'll do is I'll use this power supply to run that light over there. And so I'm going to run that set of LEDs over here with an adjustable power supply. It runs nominally on 12 volts, but this way I can adjust it and increase or decrease the amount of power there. So now I've got this power supply here hooked up to the lights, and I've got a switch on the floor that I can step on to engage the, so I got the extra 3 lights there that I can control. So this is the extra wire to ground. When you ground that middle wire, so the black wire is ground and the red wire is plus 12, which I got set to 8, which is a little low, but I can turn it up if we need to. And then this wire, when you ground it, when you ground the purple wire, it adds the extra lights on. So what we have here now, you can see, if I look at that light there, if I step down on it, the ring will be complete. So when I step down on the switch, it'll complete the ring. So now I can turn off my lights on my workbench now, and then I'll be able to see, still be able to see here, and I'm going to turn off the lights in the other room. So now what I'll be able to do close this door here, and I'm just going to close the door here. Shut off this TV here. Shut off this TV. And now most of the light's coming from this source. So now if I step down on that light, you can see the ring completes itself. So now that's just for example, we're looking at 34.8 ohms. And when I step down on it, it goes to, we're looking at 340.8 ohms, and when I step down on it, it's 325.2 ohms. So you can see the change in resistance when I step down on it. Now, what I'll do is I'll write down some numbers here. So I'm going to start by putting it back here. And what I see here. Okay, so now I have this light here, and we have a meter here, and you can see it's 293.2 ohms. And when I step on this switch here to turn on that other light over there, turn on the additional light, you can see when I step that additional light on, it goes from 293.2 ohms down to 280.6 ohms. So I'm going to write 293.6. And when I step down, the resistance will drop. So I'm going to step down on the switch. It's 280.8. 280.8 when I step down, and when I step up it goes back up to 280.8. So it's 280.8. And so now what I'm going to do now is I'm going to slide this closer until I get it down to 280.8. So I'm just sliding it along the table until it gets to 280.8. I'll go back and forth until I get 280.8. There it is, 280.8. Now what I'm going to do is I'm going to step down again, and when I step down it goes, the ring completes, all the lights are on now, and when all the lights are on it's 268.4. So let me write 268.4 here. So this is, each of these corresponds to moving it along, and then I want to get it, now that I'm not stepping down, I want to get it to 268.4. This is like solving a differential equation with a small epsilon. 268.4. So now that's where it's 268.4. I'm just writing this on. It doesn't matter where that is anyway, because we don't need to measure it or anything. We're going to try to do this without measuring anything. So now when I step down, 268.4, when I step down, goes to 256.7. 256.7. And now we're going to slide it down until it gets to 256.7. $256.7, and then again, that's like right here, that was 256.7, and we're going to step down again. We're going to see what we get, and when we step down it drops to 245.3. Now, I'm going to come back here, and I'm going to move it until we get to 245.3, and closer until I get to 245.3. There. And I'm going to step down. Now it says 234.5, 234.5. 234.5 ohms, 234.5 ohms. Now I'm going to move it now 234. Now we got to move this in closer till it gets to 234.5 ohms. .5 ohms, and then step down 224.7, or 200.1, 224.1. So it's 224.1. And then we'll move it closer until it gets to 224.1. There it is, 224.1. I'll step down, now it's 214.2. 214.2. Now we'll move this closer till it gets to 214.2. And then now we'll step down again. Now it's 204.7. Okay, now again we'll move it till it's 204.7. And now we're going to step down 195.6. And move it close till I get to 195.6. Good. And then we're going to step down. Now it's 187. Now range. See what range we want. 187 is what we want to move it closer until we get to 187. We'll step down. Now it's 178.7. And then I'll step down. It's 170.7. And then we'll move it till it's 170.7. We'll step down. $162.5. And then we'll move it till it gets 162.5. And then we'll step down 155.5. Now, let's move this closer till it gets to 155.5. And then get 148.8. 148.8. Now we're going to go from 155.5 down to 148.8. There we go. And then we're going to step down. Takes us to 142.2. And then we're going to go to 142.2. We're going to take it down to 142.2. And step it. 136. Steps down to 136. And then we come back here, slide it forward to 136. And then we're going to step down on it. 130.2. We're going to come over here. We're going to move it until it goes down to 130.2. And then step down on it. It's 124.6. Now we're going to do the same thing. We're going to move it closer till it gets to 124.6. We're going to step down on it, 119.2. I'm going to slide it closer till it gets to 119.2. I'm going to step down on it, 114.2. Closer, 114.2. Step down to 109.3, 109.3. And then move it till it gets to 109.3. And step down on it, 104.5, 104.5. Okay, moving into 104.5. Step down on it, 99.9. I wonder if I should change the range. No better, yeah, 99.9. Move it to the 109 mark. 9.9. There you go. Step down. Get 95.7. Okay, and move this to 95.7. Step down on it, 91.6. I'm just going to push this down to the 91.6 mark. Step down on it, 87.8. And gonna step down on it, 84.2. Okay, and closer till I get 84.2. And step 80.8. And step down 77.1. Now, do the 77.1 on here. Step on it, 74. Okay, now slide into the 74. Good. Step on it. 71. And then take this thing again. Set that to 71. Step on it. 68.2. 68.2. So this is just a list. I don't care where the light is. I don't care about the location of the light. I just want this list. 68.2. Good. Now, 65.4. .8. See if there's any range this improvement. More than 62.8. .3. .58. Go 58. From 60.3, we're going to go down to 58. And then step on it. 55.7. And then we're going to slide it down to 55.7. And then we're going to step on it. 53.5. Then we're going to set it down. I'm going to step on it. It's 51.3. And then move it. There it is. 51.3, step on it. It brings it to 49.2. Go to 49.2. All we gotta do is step on it to 47.3. $45.5. 45.5. So by now we're pretty close to that light source. So we're probably close enough that we might get some inaccuracies eventually if we get too close, but I think that's a pretty good spacing.